Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 8 students. Okay, so since on the previous video we have dealt with the definitions and all the important terms related to the circles, so in this video we will be dealing with a few sums related to circles. Okay, and so for those who haven't gone through the previous video, please go through the previous video, because all the basics we have already done in the previous video. Okay, so in this one what we'll be dealing with is we'll be dealing with few sums regarding the circles, okay, and the related to the terms as well. Okay, so sums, and as I've given you the topic, sums on circles and chords. Okay, from exercise 24a, your first one. Okay, so the first figure here we have is a circular figure. As I've already told you that in geometry section the figure tells you a lot, so you need to read the figure carefully, okay, and understand what are the given terms in from the figure. That's very important for geometry. Okay, so and you need to know the terms as well. See, from here what I can make out is, see, I got a circular figure, I got a center as O, I got a chord AB, isn't it? I got a line OA. Now OA, line segment joining center and circumference, so it's actually a radius, isn't it? Now what do I have is I got a line perpendicular to the chord as well. Now I know that the chord has been divided into two equal halves, isn't it? The chord has been divided into equal halves. The point where it has made perpendicular, I have marked it as C. See? Okay. So I have marked it as C. Now what do I have here is I got a triangle as well. See, OAC is a triangle as well, isn't it? Now here we need to find X. So see, the question here is about to find X. Now where is our X? OC is actually the line perpendicular to the chord. That's what we need to find, isn't it? Now what do I know is, see, the perpendicular was already given in the question. So what do I know about the perpendicular is the perpendicular divides the chord into two equal halves, and the length of the chord is given to me. See, the length of the chord is given as 16 centimeter. Now what do I know is, as I've told you, that the perpendicular, see, remember the theorem, the property of the chord, the perpendicular line from the center to a chord divides the chord into two equal halves, isn't it? That's what we know. So we know that AC and CB is equal, isn't it? And the total length is given as 16 centimeter. So now I can easily tell that AC is 8 centimeter and CB is 8 centimeter. Overall it's 16 centimeter, isn't it? So we need to find the point X. So see, first of all, let the point where center makes perpendicular point at chord ABBC. The point was not given, so I have assumed the point, the name of the point was not given, so I have assumed the point as C. Okay, now after that what I have done here is, since OC is perpendicular, so I know that OC was perpendicular. How? Because of the figure. See, this symbol, I have already told you about this symbol, isn't it? It's a 90-degree symbol, and it's also known as perpendicular. The line which is making 90 degrees is known as perpendicular, isn't it? Now, so therefore, see, and this is the symbol for perpendicular, like a reverse T, isn't it? Inverted T. So now, since OC is perpendicular, and see the explanation part, as I've been telling you, the explanation is geometry is very important, isn't it? So since OC is perpendicular, so therefore we can write AC equals to CB, property of a chord. See the explanation, the reasoning part as well. Okay, so these are very important. Okay, the way of writing is also very important in geometry. Okay, so AC equals to CB, that is a property of a chord. Now, so AC equals to CB equals 8 centimeter, as I've already explained you why it is 8 centimeter, isn't it? Because in total it was given as 16, so obviously if 16 is divided into two equal halves, it will be 8 and 8, isn't it? So 8 and 8. Okay, AC is CB 8. Okay, now as I've already told you that OAC, now it becomes a right angle triangle, isn't it? And the right angle triangle, in the right angle triangle we are dealing with the sides of the triangle. So obviously what happens, Pythagoras theorem will be applicable. I guess you can recall that, isn't it? Pythagoras theorem, I have told you everything about Pythagoras theorem as well. So see, now in triangle OCA, according to Pythagoras theorem, so what happens? Hypotenuse square equals to base square plus perpendicular. This is what we know from Pythagoras theorem, isn't it? Now in this one, in this figure, what we know, that side opposite to the 90 degree is the longest side of the triangle, also known as your hypotenuse. So hypotenuse here is OA. So see, that's why I have written OA square plus, now this one is our AC is our base, so AC is square plus, now OC is our perpendicular, that is height as well, altitude as well, isn't it? It can be called as perpendicular height or altitude. So OC square. Now where is our x? X denotes OC actually, isn't it? That's what we are after. So okay, now OA is already given as 10, so I have substituted all the values of the sides. So 10 square minus AC is 8 square plus x square. Linear equation, one variable now, isn't it? I guess you can do that. So see, 8 square taken to the other side, so 10 square minus 8 square, x square equals to 10 square is 100, 8 square is 64, so 100 minus 64, x square equals to 36. Now see this one, this step, see, I guess this will be new for you, or I guess we have done this previously as well. Okay, no matters. Okay, I'll explain you one more time. See, x square equals to 36. Now remember, we are after x, not x square. Okay, now what happens is, if you take square from one of the sides, you need to place square root to the other side. Okay, I repeat again, if you remove square from one of the sides, you have to place square root to the other side. See, on the left hand side I got a variable square, on the right hand side I got a constant term. So what I did on the left hand side was I removed the square. Soon as I removed the square on the left hand side, I have to place, as I've told you, I had to place square root to the other side, so square root of 36. Now the concept of squares and square roots, so square root of 36 means 6, isn't it? 6 into 6 is 36, or what you can do is you can simply take the factors of 36 and check as well. Okay, since it's a perfect square, I know it's 6 into 6 is 36, so I have directly written 6. Okay, so we got the value of x as 6 centimeter, and that is how it is done. Okay, let's do a few more sums, it will be easier for you. Okay, for the next one we have here is, again we got a circle. See, we got a center, we got a chord, a perpendicular line. Again here the radius was missing, OA. See, the radius is missing, and it's 0 to x. That means we need to find the radius. Now it is the radius for the circle, but for the triangle, see, OAC, because we got a right angle triangle as well, isn't it? And we are dealing with the sides of the right angle triangle. So but for the right angle triangle, it actually is a hypotenuse, isn't it? Because the length of the chord was also given as 6 centimeter, so we know that AC will be 3 centimeter, AC 3, CB will be 3, isn't it? OC is given as 1.6 centimeter, and you need to find the hypotenuse. Okay, now all you need to do is use the Pythagoras theorem, and remember the way of writing as well. Okay, it will be similar to this one. Okay, so using the Pythagoras theorem, you need to calculate the hypotenuse. Okay, I hope you can do that. So that is why I haven't done this one. Okay, for the next one, what we have here in the next one is for question number 3, we have here the figure is given as, see, we got a circular figure, isn't it? Again we got center, we got but here the length of the chord is missing. See, x, that's what we need to find, the length of the chord. Okay, so OA, the radius is given. For a triangle, it will be hypotenuse. The radius is given as 6.5 centimeter. The perpendicular line is also given as 2.5 centimeter, and we need to find the length of the chord. See, because x in here denotes from A to B, we need to find the length of the chord, but here we cannot find the length of the chord directly, isn't it? Now what we can do here is we can figure out the value for AC. Now as soon as you get the value for AC, what we know is if you double it, or if you because AC will be equal to CB, if you add it 2 times or multiply it with 2, then you will get the value for AB, isn't it? That's what we are supposed to do. Okay, so that is how we will proceed in order to find the value for x. Okay, so the first of all, what I have done here is, see, I have written let the perpendicular point on chord AB, let the perpendicular point on chord AB be C. Okay, so the point was not given, so I have assumed it as C. Now in triangle OCA, according to Pythagoras theorem, that's what we do, isn't it? In a right angle triangle, for 2 sides given, 3rd side missing, we'll use Pythagoras theorem, isn't it? That's what we have already discussed before. So OA square, that is hypotenuse square, equals to base square plus perpendicular square. Now after the calculations and all, I guess you can figure out the calculations. Okay, So OA is 6.5 square equals to AC. AC, that's what we need to find. So AC plus OC is given as 2.5. So 2.5 square. Now 6.5 is taken to the other side. It will go as minus. Plus will go to the other side as minus. 6.5 square is 42.25. Minus 2.5 square is 6.25. After subtraction, you will get 36. Since we are still having square, so we need to take out the square. So I see on the second line, as I've already told you in the previous sum as well, whenever you remove square on one of the sides, you need to place square root on the other side. Square root of 36, so square root of 36. Now what we got? Remember, we got the length from here to here, not the length of the chord. Okay, we got AC as 6 centimeter. Now what we know is we know AC equals to CB, isn't it? Now say X equals to AC plus CB. AC plus CB, and since CB equals to AB, CB equals to AC, CB is also equals to. Why so? Because of the property of the chord, isn't it? Perpendicular. So therefore X equals to AC plus AC, that is 6 plus 6, and we have X, the value of the length of the chord, as 12 centimeter. Okay. So the next question we have here is, again, see, I haven't done this question. I'll explain it and you have to do it. Okay. In a circle with center O and radius 13 centimeter. So I guess the figure was not given. I have drawn the figure. Okay. Suppose in the questions where figure are not given, please draw the figure. It will be easier for you to know. Okay. In a circle with center O and radius 13 centimeter, AB is a chord. If OM is perpendicular to AB, OM equals to 5 centimeter. What is the length of AB? So see, what I've drawn here is I've drawn a circle. I've drawn a chord AB with center O, isn't it? Now see what the question states. AB is a chord. OM is perpendicular to AB. So the line is perpendicular to AB is OM. So I have drawn OM. See, the point is M, is perpendicular. So, and see, radius is 13 centimeters. So I need to join O and A, or you can join O and B as well. It will be similar, isn't it? So OA equals to 13 centimeters. That is the radius. And OM equals to 5 centimeter. OM, the length of the perpendicular line is given as 5 centimeter. Now we need to find the length of the chord. So now this question is similar to the previous one, exactly similar, isn't it? So everything, the procedure will be same. I hope you kids can follow that, isn't it? Do that. So that's why I've left this one, okay, for you to do by yourself. Okay. Now similarly for question number 3 as well. See, in a circle of a radius 17 centimeter, again, find the distance of the chord of length 16 centimeter from the center. Okay, the length of the chord is given here as 16 centimeter. So in a circle of radius 17, the radius is also given. So see, I have drawn a figure. Chord, I have drawn AB. I have drawn all the necessary lines and all. OA, that is radius. Now the perpendicular line OC I have done, isn't it? Now what we need to find is find the distance of the chord of length 16 centimeter from the center. So we need to find the distance from the center to the chord. That is, we need to find this line, isn't it? Distance is this line. So that's what I have drawn here. See, chord, center. From center I have joined a point O. That is the radius, 17 centimeter. The radius was given. The length of the chord was given as 16. So that is why I have written here 16 centimeter. Now you know AC will be equal to 8 centimeter. It is similar to the previous one, isn't it? The first one. All you need to do is find the perpendicular from the right angle triangle. Okay. So again, this two is using Pythagoras theorem. So I guess you can do that. Do this too. Okay. Now for the next one, what we have here is, see, circles are concentric. Now this term is new for you, isn't it? Circles are concentric with center O, and find AC if OM equals to 8 centimeter, OC equals 10 centimeter, and OB equals to 17 centimeter. Now we see what does concentric circle means first of all. Okay, circles are concentric. What does this term mean? Concentric circle means circles having same center. Okay, so what you can do here is basically see, I've drawn two circles, but for both the circles the center will be same. Like see, how will you draw a circle? You will be drawing a circle using your compass, isn't it? So the gap between the pointed end and the pencil will be your radius actually. So first circle drawn, and all you need to do is just change the radius, okay, in order to draw the second circle. That way, from the same center, if you draw two circles, then those two or more circles, then those circles will be known as your concentric circles. Okay, so here, according to the figure, what we have here is I got two concentric circles. I got two chords as well. See, for a bigger circle, I got chord AB. For smaller circle, I got chord CD. Okay, now I got radius for both the circles as well. For a smaller circle, I got 10 centimeter. For bigger circle, I have 17 centimeter as the radius. See, and I got the distance of the perpendicular line as well. See, it's 8 centimeter. Okay, now what you need to find is, say, find AC if OM equals to, okay, all the terms are given. I guess the figure for this sum is given. Okay, so OM is given as your 8 centimeter, that is the distance, perpendicular distance is given. OC is given as 10 centimeter, smaller radius. OB is given as 17, greater radius. We need to find AC. AC means this distance we need to find. Now see, okay, in order to find this distance, how will you find this distance? First of all, let's see. So for the bigger chord, okay, for the bigger chord, see, suppose if I have taken triangle OMB, if I have taken triangle OMB, because I know that this line is perpendicular, that means for bigger circle, bigger chord as well, the bigger chord is also divided into two sections, two equal halves, isn't it? So if I take OMB as the triangle, and I have for OMB triangle, the hypotenuse is given, the perpendicular is given, all we need to find is base. And for smaller triangle also, so at that time I will be getting the value for MB from the bigger triangle, isn't it? I will be getting the value for MB. Now I know that MB is equals to AM, isn't it? So similarly, if I take smaller triangle, that is OCM, okay, at that time what happens is you will get the value for CM, isn't it? Because the perpendicular is given, see, hypotenuse is given, you will get the value of CM. Now simple, you already had AM, and if you get the value of CM as well, so we need to find AC, isn't it? So if you subtract CM, that is this section from AM section, you will get AC. Simple. From this line, if you remove this line CM, removing means what? Subtraction, isn't it? Then you will get the value for AC, isn't it? So that is what I have done here. See, I have written, since AC will be equals to AM minus CM, that's what I have written here. See, AC is equals to AM minus CM. Okay, so in triangle OMB, so first of all I went for the bigger triangle. So in triangle OMB, okay, OMB. Now according to the Pythagoras theorem, I guess you know the calculation part and all, isn't it? So I won't be explaining the calculation much, okay, because I know that you know the steps. That too, the Pythagoras theorem we have already done. So all the hypotenuse, you know about the hypotenuse, base and all, isn't it? So from triangle OMB, using Pythagoras theorem, what we figured out was, we figured out the base, that is MB. Base was your 15 centimeter. Now this is MB is equals to AM, so that's what I have written. Since AM equals MB, so AM equals 15 centimeter. Now again, as I've already told you, in triangle OMC, according to Pythagoras theorem, again in triangle OMC, that is this triangle, small triangle, again from there too I have figured out the length of the base, that is CM equals to 6 centimeter. Now from this line, that is AM line, if I take out CM line, subtract CM line, I'll get the value for AC, isn't it? So that is what I have done here. See, therefore AC equals to AM minus CM, so AM we got as 15, so 15 minus 6 is your 9 centimeter. So this is how you get the value for AC as well. Okay, I hope you kids understood. Okay. Okay, now for this one, that is question number 5. What we have here is a chord distance 2 centimeter from the center of a circle is 18 centimeter long. Calculate the length of the chord of the same circle with 6 centimeter distance from the center. Okay, here we have two chords on the same circle. Remember, we got two chords on the same circle, and the length of the distance from the center is given. See, a chord distance from 2 centimeter from the center of the chord is 18 centimeter long. Okay, so first of all I have drawn the chord which is 2 centimeter distance from the center. Okay, and it is 18 centimeter long. The length was also given, isn't it? Now what we need to find is calculate the length of the chord of the same circle which is 6 centimeter distance from the center. Now what we need to figure out is we need to figure out the length of the chord, another chord which is at 6 centimeter distance from the center. Now first of all, so after drawing the figure, or if the figure is not given in the book, then how will you draw it? First of all, you will draw a circle, isn't it? You will draw two chords, distance as 2 centimeter and 6 centimeter. You will draw perpendicular lines and all, isn't it? Now see the most important part in here. What is the most important part in here is from here I can easily calculate the from the first figure. Let's see, from the first chord, the length of the chord was given, so AC was given, so we can figure out AC. AC will obviously be half. That's what I have done here, half of 18, that is 9 centimeter. See, AC already done, isn't it? Because it was perpendicular. Now see, what is the relation between these two chords? That is most important thing, isn't it? We need to figure out the relation first, how to proceed, isn't it? Now see, OA, what is OA actually? OA is the radius of the circle, isn't it? Now similarly for another chord, if you draw a line segment joining O and E, now E is in the circumference, as you know the chord will, the point will be in circumference. So what is OE? OE also is a radius, and what we have learned from the concept of radius, that is, no matter how many radius you draw in a circle, the length of all the radius will be equal. That's what we know, isn't it? So from the first figure, if you figure out the radius, that is OA, and how will you do that? Using Pythagoras theorem, isn't it? When you will use Pythagoras theorem, OA will be your hypotenuse. So when you figure out the Pythagoras from the Pythagoras theorem, the hypotenuse, that is OA, the radius of circle, OE will be also be same because it's also the radius of the circle, isn't it? And that how and after that what we can do is we can figure out the value for EF, isn't it? EF, then how will you get the length of the chord? All simple, double of EF, isn't it? So that's what I have done here. See, now in triangle OAC, according to Pythagoras theorem, that is this triangle OAC. So the base is 9, the perpendicular is 2 centimeter, and we need to find the hypotenuse, isn't it? So that's how we got the hypotenuse. See, OA squared equals AC squared plus OC squared. All the values I have substituted, all the values. 9 squared is 81, 2 squared is 4, so 81 plus 4 is 85, and OA equals to square root of 85. Now since we 85, it's not a perfect square, so I have kept it in square root. Okay, square root of 85. Now in the second triangle, that is triangle OEF, according to Pythagoras theorem, the second triangle, this one, OEF. Okay, so let's turn the figure. It will be easier for you to see. OEF. Now what do I get is I have OA as square root of 85. Now that means, as I've already told you, OA is equals to OE because it's radius, isn't it? So OE now also will be equal to square root of 85. Now I got perpendicular, I got hypotenuse, I can easily calculate the base. Now once I got the base, if I double it, I'll get the length of the chord, isn't it? So that is what I have done here. See. Now in triangle OEF, according to Pythagoras theorem, so what I did was I figured out the value for EF. See, using Pythagoras theorem, hypotenuse square equals b square plus perpendicular square. So now see, the hypotenuse actually was the radius, isn't it? So square root of 85. Now see, square root of 85 square means 85. Okay, square root square. Whenever you use square on square root, all that happens is you can directly take out the square root. Okay, square root of 85 square means 85. So 85 will be square plus 36. Now doing all the done all the calculations and all, 85 minus 36 is 49. So you got EF as equals to 7 centimeters. So I haven't completed the sum. See, yeah, I got EF equals to 7 centimeters. Now actually what we needed to find is calculate the length of the chord, isn't it? So now what are you supposed to write? You are supposed to write that length of the chord. Now the chord was here, it was actually DE, isn't it? So the length of the chord DE will be equal to, as you know, it will be equal to 2 into F equals to, isn't it? So 2 into 7, that is equals to 14 centimeter, the length of the chord. Okay. Okay, so I hope you kids understood today's lesson. Okay, so stay tuned in for more updates and videos. Till then, stay safe, take care, bye bye. And I want you to complete the sums as well. Okay.